Hello, Internet. Enduin here. Today I wanted to share the development process of the game Enduin. But I've never streamed before, so I'm going to be taking a minute here at the beginning to sort of figure out what's going on. Okay. So it looks like I am live, so that's good. Settings, analytics, health. All right. So I'm developing a game with sort of a working title of Enduin at the moment. And it's a 3D voxel game. I haven't prepared anything for this because this is a live stream. I'm used to being prepared. Anyway, so uh, nobody's here yet to hear this, but if anybody goes back and watches the beginning of a stream or like a stream later or something, I want to say what this is. So this is my project. Unfortunately, it is already underway. I'm not starting fresh. In fact, I've started a long, long time ago. It's gone through several iterations. This is a 3D voxel. Okay, now YouTube is spamming me. Gosh. Also, I might need to double check. I'm going to check some audio stuff. I need to make sure that the audio that I'm hearing is not playing through because I'm listening to music. Okay, awesome. It's not coming through. So, all right, let's get into it. So I'm building a game. I'm using the Godot engine underneath. This is the C# script project that's going to go on top of that. I want a Godot so that I've got C++ to move things to when I need to optimize them, because I'm going to. And that's the core of it. I grabbed the source code of Godot and I built a version of it. Basically, it was like a beta version of 4.0, something like that. I haven't upgraded it to the latest again. And anyway, the game really has nothing right now. It's a 3D voxel game. Can't do anything. Just a basic scene with some random stuff on it. And a bug when I end it, when I exit it. Memory exception when I leave. Anyway, so 3D voxel game platform. I want the platform. Basically, I kind of like what Notch was saying and was planning to do with Minecraft. I want to actually do it. And on top of that, basically to flesh out the platform, I'm going to build an RPG with the standard storyline, nothing particularly special, just a game that you can play in it, so that if you just grab it and play it, you have a game. You play it all the way through, and then you can really take the platform and use it to build the game you want. Or build all sorts of other games within it, like people do in Minecraft, but with actual API support. With well, okay, they've made several improvements since I started this project a long, long time ago, that I was already planning to do, but they did make some good moves, like not just texture packs, but full resource packs with scripting and stuff like that. Anyway, that's what this is. Now I'm just going to dive in, and until people show up, I think I'm going to start, just start coding. How do I see? I don't see anywhere where it says the number of people that are here. Why does it not say that? That seems like a crazy thing not to show me. Huh. Well, like, because then I won't know if someone shows up. Well, I guess I'll know if they talk. All right, so I'm going to get started. I'm going to start out by trying to... So you saw the state of the game is just nothing. You just stand there, you spawn in. There's a little model to show and a couple of cubes for like positioning to know where I'm at. I've got stuff loading from component file definitions. Pull one of those up here. got this like concept entity model program, scene texture. I'm getting a little distracted by YouTube's playback here. Scene texture voxel. I want to go with entity. Oh yeah, one of the first little enemies is called an ankle biter. All right, let's. All right, so here's how I'm defining everything. It's going to be kind of like Warcraft 1, where if you want, you can go in and edit the range of an archer to go all the way across the map. If that's how you like playing, you go right ahead, you know? I have so many things on my other window. All right. So yeah, it defines it, some versioning, schema versioning stuff and reference keys, IDs, stuff like that. And then standard like entity component system here where this defines that this is a corporeal entity. If it's visible, what's the constant key of the model to reference? If it can aim, that allows you to move the mouse around and look. If it can move and attack and stuff. So that's the stuff that I'm loading in already. A bunch of this. And then I kind of need to use it now. So I have a bunch of like structural stuff built. Mostly no meaningful functionality yet. So I think in the engine scene, I had next. Oh, not the scene, the engine. Here we go. So I've got some code from an old. Originally, I was just developing this within the Godot source code itself, like I may do. I may move some stuff into that, but I realized that wasn't the best way because then like I can, but Godot is a tool to generate a game. So it's best if I add the things to it that I need to be able to generate the game that I want rather than building my game in that. Because there's some weirdness about like you build it and then run it and it runs Godot, not your game. And so yeah, I was kind of building it in the wrong way. It's the first time I've ever tried to do stuff like this. So now I'm just switching to this and I've got a bunch of the C++ code to adapt. So when we run and we start, I can't move. I'm pressing W, nothing happens. That is very obnoxious. I really need to fix that, but I'm not going to fix it right now. Where's that at? Engine. All right, so what's happening? I've got all kinds of math stuff happening here. End up jumping, move the entity. Okay. So I'm figuring out where I need to move. Move entities plural. Look for the controlled one that your entity that you're controlling currently. Grab a bunch of the components and things about it. If you can aim, calculate your aim, get a bunch of the angles and stuff. I thought I had this working. Why is it not? Hold up. I feel like I accomplished this already. Am I forgetting something? Aha, yes. There we go. Press E to connect and disconnect the mouse here. All right, cool. So yeah, aiming works, but then moving doesn't. So what we want to do is a very similar thing. So here we've got aim. If we're aiming, figure out where we're going to aim. I'm really nervous about copyright stuff here. Let me check audio one more time. Okay, cool. All right. Okay, so let's see, horizontal angles. Yeah, and then I get the basis, scene entity, global transform. So I'm modifying its aim here. Point the head to where we're aiming. Oh yeah, you got to do these two things separately because you don't want the body to rotate. Let's see if I can demonstrate this. So I've only got the two cameras, so not in a great spot right now, but you can see how the head is moving, which is still not ideal. It's kind of disconnecting from the body. Oh, right. I'm rotating it around the wrong axis, it looks like. But you want the body to turn with you on the X and Z coordinates, but you don't want it to move up and down when you look up and down. So you got to kind of do two things. What if I just skip to that? There we go. So first I rotate the body by doing that. Scene entity and then the head node. Right, which the head node is, I grab it out of here. It's really hacked in right now because pulling models from Blender in is pretty complicated and messy with the whole bones and skeleton and stuff. But that's things that can be fixed later. First, I want to be able to even walk around because I'm not using just the like drag and drop in standard controllers and stuff. Because I'm going to customize this so much, it doesn't really make sense to. Like the game, I'll probably never finish this, but if it's going to be way too big to just use, you know, drag and dropped, whatever it's called, pre-built stuff. That stuff is good when you're making something small and you don't have to deal with it in a large code base. But I'm gonna end up with a very large code base, so I'm gonna put a lot of time in keeping that maintenance down. All right, so update the velocity if it can move. So here we're figuring out its new velocity. And then deal with jumping, change its velocity if it's going to be like moving into the air and stuff, which I'm not ready for yet. It's just copied over from C++. And then actually move the entity. So I think I'm supposed to pull this stuff down into the move entity. Why did I separate this? I feel like most of this should be in move entity. Let's see. Adapt the C++ code and clean it up. Yeah. Get node. Entity. All right. Where is it at? So I have CPP file. Do I have it open? No. Moment. I'm gonna grab that file. Up from a past client here. Clients are the because this will be server client as well, but servers you'll be able to. One thing I really want to do is allow you to run one world with multiple servers. You know, have different servers processing individual parts of the world. So you can scale a lot better than like a Minecraft server can scale, where one server has to do everything. Oh, another thing is the main game is not going to have randomly generated terrain. Or like there'll be procedural generation, but I want to custom craft a world. It's way more interesting that way. So, sorry. Okay, so client, boom, and then I need engine. Where we at? Simulate. Master engine. There we go. Engine network. There we go. So here's all the code that I wrote before. Woo! This is all the C++ stuff that I had built. I'm recreating it now, mostly in C#. I'm not going to throw this away because a lot of this might get used in as I move bits into C++ to optimize things later. Only 10,000 adds jitter. Oh, yeah. Oh, I remember that problem. All right. So what we're looking for is process. Is it task list I've got? I did it. I made a thing video. Entity input. Algorithms. I had an algorithm for generating like terrain. It says entity actions. There you go. Move entities. Here we come down here, and then this is where that code came from. Move entity. Okay. So I'm getting like different components of it, and then now I need to deal with actually moving the entity, which is so complex. It's so hard, and it turns out Minecraft's movement is very complicated, especially since I'm not operating on moving things tick by tick, which I might actually need to change. I don't really want to change it. I don't want individual ticks, but I think when it comes to physics, I do want things to be consistent, so you know exactly what they're going to, you can replicate what they're going to do. If you start with the same random seed, not of the procedural world, but like just in general, if you start with random, a random seed instead of like time-based, then you can reproduce what was happening. So I want that seed. If you use the same seed, you can get the same output. But I think if I move things based on delta time, then that's going to be, their movement is going to be dependent upon the user's rendering speed and ability. That's really interesting. That sucks. That really sucks. I didn't like that. I was like, why don't you just use, why do we have 20 ticks per second? Like, why aren't you just rendering as smoothly as you want, everything exactly in a certain spot? And now I'm seeing why. It's because if you can render 100 frames per second, your stuff will move differently and it won't be predictable. It won't be reproducible because there'll always be that slight difference as you have a floating point time change. And then if you pick too many ticks per second, then any computer that can't manage it will run the game slower. So 20 is probably the right move, even though what I really want to do is like 100 or 60 or something. But if your machine can't process, if I do 60 FPS, not FPS, because the rendering can be done in different speed. But if the movement, if the change of entities in universe, because I have that isolated out, I've got the universe, which has no concept of rendering or, well, it has a little bit of audio and stuff or control or whatever. It's just, this is the universe of entities and voxels, and then where they're at and what they're doing. And then the renderer can like see that and look at it and inspect it and figure out what to display based on the current state. But that state does not depend on what you're rendering. Unless I make this engine do that, which I'm kind of doing right here. If I change the state of the universe based upon the delta time, then yeah, that's different. All right, figure out how this works without considering delta time. There we go. Maybe move and slide with snap causes something later during a physics step that already uses it. Oh, right, because it's not using delta time. Move and slide with snap, I think, doesn't do that. And I don't want the movement is going to be way more, well, okay, as I've learned, Minecraft movement is actually pretty sophisticated. It's going to be different. I don't want to make it move the same way. I want to make it feel good, and then I want to change it to improve it and do a bunch of stuff with it. All right, so here's my C++ code. Move the entity. Where's move and slide? Move the scene entity. Oh, yeah. That's right. Movement precision scale. Add entities. Okay, so I think something I'm doing wrong here is I'm having the engine change both things. It's like telling so much code here. So I'm moving the entity in universe here. YouTube spamming me again. Okay. So I'm moving the entity in universe here. Figuring out, are you on the ground? Is there drag? Deceleration factor. I've got all these notes about trying to figure out like what a good curve is to make it feel good, because it didn't feel great. You either like kind of slow to a stop like you're on ice, or you're moving super fast and then just instantly stop. And moving 100 miles an hour, you'd come to the stop, you know, within basically this. You couldn't tell the difference between how fast you stopped there and if you're walking and stop. It's like, that doesn't feel right. All right, so I moved the scene entity by setting its velocity. So I think I need to set its location. Oh, right. Okay, so I have a little bit of a conundrum here. Here I'm trying to set the location in the universe, but that's really complicated with all of the collisions and all the collision entities and stuff there are. So I wanted to use Godot's built-in position, set position, see location. Wait, where is it? Move and slide. There we go. So if you're walking, move and slide. So Godot has this built in. And what I was doing is basically just using it to do the movement and then setting the universe entity's position. Yeah, here we go. Here's the entity, the scene entity. Wait, am I? Scene entity. Where am I setting? Simulation delta move, corporeal volume, translate. Okay, so here's where I move the entity's volume in universe based on how much Godot told me it moved. Okay. How long are we going here? 25 minutes. Thinking maybe let's just keep this short. Do a little hour-long stream as my first one to see how this all works. Hmm. Thinking about moving and doing it myself here. Set velocity. Move and slide. It seems like I feel like this is a hack for now. I'm going to have to change it anyway. Let's move back up to here. Oh, yeah, without considering delta time. Okay, so we come down here. I get all this velocity and I set all this stuff, right? And I say, hey, here's the scene entity. That's the Godot object. In fact, let me see if I can... What? Oh, right, it is in C++. Well, anyway, this is derived from like a Godot node or whatever. I set the velocity, right? And then I say, move and slide. Over what frame of time? How does it know? How much is it doing? 1 unit of velocity, I guess? Guess that makes sense. I can set velocity. Oh, because velocity is per second. Right? It's just like, and then move how many per second. So, all right, I think I might need to open a whole another instance of the old one. All right, let's see if I can get the old project that was in C++ where I can like reference back to the Godot code. So here's all of the Godot code. It's pretty big. And then all my code built into that. So what do I have here? Renderer. I'm doing render. So what I want is into an engine. Here we go. We're working on the movement. This run command. Oh yeah. All right, I'm way too long. Why is this all broken? It says nothing works here. I'm just trying to get to that movement code. Mobile. No, that's not right. Entity input. Step algorithm, remove algorithm. Wait, there we go. Process entity actions. Move entities. I feel like it's not going to let me jump because it's got all these errors for some reason. I may not have worked on this machine. There we go. Move and slide. Oh my gosh, it works. Okay. Character body 3D, move and 5. Move and slide. Physics body 3D. Oh, that's not a good sign. This is the Godot code. So, oh my. Okay. Hack in order to work with calling underscore process from underscore process wells underscore physics process. Calling from thread is risky. All right. Get singleton is in physics frame, blah, blah, blah. Oh, delta. Oh, here we go. That's how it does it. And this is a hack. All right. So delta, get singleton. If you're in the physics frame, get the physics process delta time. Otherwise, get process delta time. Okay. So it does use delta time. That's how it does it. Delta. Where are we at here? Here we go. So motion parameters. Current platform velocity times delta. Well, that's the platform. Move and slide grounded. Delta. Parameters. Exclude bodies insert. Exclude bodies. is trying to figure out how this does anything. Because it uses delta to figure out, and the current platform velocity. But if you're grounded or floating, yeah, then it does delta. So it's using the delta here, but it's not using the current platform velocity to modify what your delta would be. Platform on leave, platform do nothing. Okay, so this is just some standard movement stuff. All right, to get my delta, locked axis, velocity equals 0. Oh, so if you lock an axis on this character, then it doesn't allow it to move that way. So I guess that helps with like 2D. Well, no, it's 3D, but whatever. Okay, so just removes one of them if it's not supposed to move in that. Get the transform, so just grabbing some values, your last position, the platform velocity that you're on, which it just sets to this, which is set where? Where does this value come from? Character body 3D. Platform. How is it after? I'm just trying to find where this is defined. Oh, this is C++, right? Sorry. Okay, this is C++. So this would be in physics body 3D. We're in scene 3D. Okay, so if we go to the header files. Up here. Oh, whoops. Let's see. Scene 3D physics. It just starts with scene. Okay, so under modules, scene 3D. Physics body 3D. Platform velocity. There we go. Okay. Yeah, platform velocity is just... So for some reason, I thought these were like underscored. Because they use underscores here. Okay, so they're keeping track of the platform velocity as part of this physics body. All right, and then just grab that current value. So then what are we doing here? If your collision is on the floor or wall, or the platform is set, then if it's floor, exclude... What is this doing? Excluded equals if this and the platform layer is 0. That feels so backward. Okay, so you have the layers that the platform floor is on. And you're trying to see if it's the platform layer. You and them together, so that's the only thing you're checking. And if that's 0, it means you're not on the platform? It's really confusing, but okay, they're setting something to exclude something. If not excluded, else if it is excluded, current platform velocity equals 0. Okay, so we're seeing if we need to exclude the platform. I don't know why you'd check the walls for that. Platform wall, I guess. Okay. Body is removed or destroyed. Invalidate the floor. This approach ensures the less delay between the actual body velocity and the one we saved. Body get direct state. If BS. Was this body state? Yeah, body state. Local position. Origin minus the body state origin. What's GT? The global minus the body state. Gets your local. Okay, and then current platform velocity equals get velocity at local position. That seems very complicated. Okay. So this is all about setting up the platform and setting current platform velocity to the value we want to use. So we start with what the value is, but it seems like we got to do a bunch of work to make sure about that. Motion results. I guess we're going to clear those out each time. Was on floor. Collision state, last motion. Current platform velocity is 0 approximately. If it's not approximately 0, then put together some parameters. Recovery as collision. Also report collisions generated only from recovery. What the heck is recovery? Parameters, exclude bodies. Exclude bodies. Exclude bodies. Insert the platform. Okay, so here's... We're trying to exclude the platform from stuff. So more platform. The platform stuff seems to make this really complex. Or maybe just the real stuff is in here and this kind of wraps it just to do the platform parts. All right, so motion result, floor results equals motion results. Oh, move and collide. Oh, wow. So if the platform has a thing... Oh, I think this is dealing with with you moving on a platform. Because a platform is not necessarily flat. So it's entirely possible that your flat, what's it called? Your non-flat platform, as you move around on it, you need to collide with stuff. So I think it's doing that. It's moving and colliding relative to the platform here. And then motion results in the keeping track of the movements from the movement on the platform. Now collision state, set collision and direction. Collision direction, floor results. Okay. All right, and then we move on to if you're grounded and if you're floating. So those are very different. That's interesting. I guess friction doesn't come into play if you're floating. Compute the real velocity. So real velocity, get your position divided by delta. Position delta divided by delta. Get position delta? What's this doing? Previous position. Huh? Were we not... Oh. Okay. Okay, got it. So now I understand. We did the movement. Okay, we moved and we slid along edges and walls and grounds, whatever. Now we're trying to update the velocity. And so we're saying, okay, where did you actually end up divided by the delta time? And that's your new velocity. The actual velocity given that you ran into a wall or slid along something. Okay, so platform on leave. If platform do nothing, add last platform velocity when you just left. So collision state floor and collision wall. If those are not because you just left it, you were on it and now you left it, then if add upward velocity and the dot product of the velocity and the up direction is less than 0. Oh, that's interesting. That would take me a bit to figure that out. Then current platform velocity equals, see this, and let me finish it. Current platform velocity dot slide. In the up direction. Velocity. I'm a little confused. Maybe, so I think might be happening here is the real velocity is your local velocity relative to the platform that you're on. That's because that's your base. If you're floating, if you're on a plane in the air, and you move, it's not keeping track of your velocity from the ground. It's keeping track of it from the plane. So it does that. And then what it needs to do is it needs to add to your velocity the platform's velocity again. Because what it did was it calculated your local one relative to the platform you're on. But you're not on the platform anymore. Oh, that's what it is. You're not on the platform anymore. Okay, so now it needs to say your velocity is no longer relative to the platform. Now it's relative to the global. So add that velocity from the platform onto yours to get you back into a correct state. Oh my gosh. And then I think it just returns like whether you ended up moving it anyway. Okay. So see, this is the stuff I don't want to write myself. Like Godot already wrote all this. It's complicated. A lot of smart people already did this work to figure out all this complicated stuff and deal with all these complicated conditions and test all this. I don't want to redo it. But my problem is they're making all these modifications to the scene entity, like the rendered thing in the scene, right? I want to move something in an abstract world, not based on what you've currently rendered, right? Like let's say on one person's machine, it renders a bit faster and it manages to, like, you're moving quickly, the game gets a little behind, and then it renders a block in front of you. The slow person's computer doesn't quite manage to render that block yet, and so it doesn't have the collision box created in the scene. What I want to happen is the game, when it moves you in the simulated universe at where it sees, oh, there's a block there. You know, oh, I'm going to move you here. What is there and what is between you? Oh, there's a block. You got stopped. But I may not have been able to get to the rendering that yet, and so I don't have the collision box created for Godot to know that you've run into that. So what I need is more like generic versions of these methods that do all of this work but aren't worried about what the render state is. So that's why I feel like I'm not sure I can use this. Because really what the source of truth of what happens is the simulation. And then what you see is just a reflection of that. So I might do that if it's a server client, for example, and on the server in the simulation, you run into something and you stop. And your client hasn't caught up to that yet. It's doing some prediction. You know, it just uses Godot scene to, like, here, you moved here. And then it goes, oh, shoot, actually, there was a collision box there. That's not where you ended up. Then the server will correct it and say, nope, actually, this is your location. And the client will bounce you back, which is unfortunate, but that's, you know, latency and stuff is really, really difficult. So that's what I want to do. I definitely can't have the server running the simulation and rendering for everybody, right? And so I'm not sure I'm going to be able to use these. But let's see. Maybe there's a way I can set it up to not be interacting with the scene, but kind of like a fake scene that I generate. So, because if I just create one of these objects, maybe it doesn't know about the real scene. So move and slide grounded, move and collide. Let's go to move and collide, 3D. All right, 3D. Result, blah, blah, blah. Restore direction of motion. If cancel sliding. If colliding. Okay, where do we set? If colliding. How do we know if we're colliding? Colliding equals body test motion. Physics server. Body test motion. Interesting. So I wonder if maybe what I need to be doing is creating multiple things. So in the simulation, maybe it creates it runs the physics server. It just doesn't render anything. And so the physics server, it would generate those the collisions and stuff in order to do its work. Update shapes, get space, test body motion, 3D. Give me back regular physics engine logic. This is madness. Oh, God. Oh, no. Oh, no. Okay. Okay. Wow. And most people using this function will think what it does is simpler than using physics. This took about a week to get right, but it is right. Who knows at this point? Oh man, I love that they gave me this comment. That really helps me in figuring out, whether I want to use their stuff, whether I want to go and, use the Godot spaces in the physics engine to figure out where my stuff is. Most of the reason I wanted to use Godot is just the scene management for rendering. I don't want to deal with Z layering, the double buffering, mapping textures onto vertices. Well, I still kind of have to do that. Shaders, God, there's a lot, and that's really the main thing that I want it for. Otherwise, I kind of want to just write all this stuff myself. But this kind of comment is really scary because if I'm going to write it myself, this is going to suck. Oh, man. Okay. Shapes found. Get shape count. Wait, what do you mean get shape count? P body. Oh, you got to test each of the shapes in the body for colliding with stuff. Okay. So, okay. Wow. Recovered. Step 1, free body if stuck. Do loop. Guys, CBK, what's that? Call back? Max amount and pointer. Oh, come on. What? Shape collide. Okay, here we go. So loop through each of the shapes. So J is our shape index. So P-body get shape. Here's the body shape. Unless it's disabled. Then for I is less than amount, with priority amount, col AABB for body. I don't know what that means. Okay. Collide object equals this. Intersection query results of I. When did you set that? What? Where is this set? You just already have values in it? Intersect point. These are all using it. They're not setting it. Space. I mean, I guess someone could be setting it if you're passing it in. Amount, cast motion. Oh my God. See, this is why I don't want to necessarily rewrite all this stuff. It is complicated. Oh man. This is why I was thinking about, or why I had initially used move and slide, and then like, so what actually happened? Oh, okay, let me go update the simulation, when really I should go the other way around, because this is all the work that they're doing to figure out the location. Oh man, this is intractable. Like, where does this thing get set? It just has a ton of values all the time, and it gets used over and over. Oh man. Okay, let me jump back into here. Here we go. Okay. It's a step of stuck, recover motion, while recover attempts. Step 2, attempt the motion. Again, we're using intersection query results, which I don't even understand how that's getting set. It's just magically there. Solve distance. Just do kinematic solving. Just do it. I love these comments. Steps should be customizable. Oh my God. Okay. Important optimization for this to work fast enough. Sep equals motion normal. What is sep, guys? Why are you naming... You need to name your variables better. Separation? Solve distance. Boy, that's a thing. Just solve. Solve the distance. Oh, man. Did it not collide before? When altering this, colliding again. Long motions. That's true, because it could collide multiple times, right? Like, if you're allowing sliding, say move and slide. So I run forward and I bump into a wall that's, 2 degrees off from my direction. You don't stop me, you just redirect me and then continue moving. But then before I finish moving, I might hit an actual wall in front of me. So you actually need to keep track of like multiple collisions along this path of sliding. That's going to be messy. And I wish I could say, oh, I have cube voxels. It's going to make it easier. No, because you can move in any direction. So it's going to be the same problem. All right. Sadly, it's the best. If stuck, safe is 0, unsafe is 0. Best shape equals J. Yeah, of course. The best shape equals J, guys. Like, come on. What are you doing? Like, I mean, it's sad that it's J, but naturally it's J, right? Like anybody would understand that. Wow. Whoever wrote this stuff, you got a big brain. This is some scary code to encounter. It collided. Let's get the rest info in. Unsafe advance? What does that mean? Allowed depth can't be lower than motion length in order to handle contact at low speed. Okay, well, this has gotten past my comprehension by a lot, of course. So let's unwind. So we've got body test motion. Body test motion. So when we do the actual collision, it goes to a physics server, and that's where it tests the motion and determines if it's colliding. And I think it gives some output results that we use to move. Yeah, see the result gets used to travel and remainder and all this stuff. Apply adjustment to motion. So move and collide does this very complicated physics server movement processing. In order to avoid sliding due to recovery. Only if collision depth is low enough to avoid tunneling. Ooh. Ooh, see, this is the kind of comment that makes me think maybe I should not just use the hack of tracking what am I saying? Not just use the hack of tracking of taking the resulting movement and setting it in my simulation, but intentionally do that moving forward. Because there are some very complicated things, like when you move, I know in like early days, online servers and stuff, 3D stuff, people would come up with bugs, like find ways to move through walls and stuff, such. Because determining what you collide with along a path is actually really hard. Mario falling in Mario 1 and landing on a block and not going through stuff, it's actually really hard to solve. If he doesn't have like a limited velocity that's less than the possible whatever. So there's some crazy stuff that can happen, such as tunneling. Maybe what happens is you move along. I think the recovery they're talking about is like is that 2-degree wall I'm talking about. I move forward and I bump into the wall, but I'm embedded in the wall slightly, so it recovers me out and then adjusts my motion. When motion is null, recovery is the resulting motion. Sorry, it's okay. So anyway, so then it'll bump me out and i.e. recover me. And then it wants to make sure that I don't do more sliding from the recovery itself. Like if I'm walking down a hallway and there's a wall on left and right side of me and they're both angled 2 degrees in, well, what we don't want to have happen is I move forward, one of the walls pushes me into the other wall that then doesn't know what to do, and I'm tunneling through stuff because of that. So this is very complex. If sliding. So I'm thinking if I write this, what I write is I do like they're doing a test of motion, and then I return back all the things you'd collide with. Is that the best? I feel like the loop would be better up here. Like I think if I started it, I wouldn't do that and then do all of this complicated logic of where did you move, what did you bump into, and how did you recover, and then from that point, what did you move? I think I would say, okay, this is how far you're gonna move, and here's your vector. And then I would do the test motion, and it would say, here's the first thing you hit, here's where it's at, and its angle, and all of the information about the collision. And then it would return. And I would have a loop out here. And that loop, what it's going to do is until I've moved the right distance, it's going to keep calling. So I move forward. It says, hey, you collided. Now I know that I haven't embedded myself in something because I got the first collision. No, I take that back. I take that back. I don't know that because of the complexity of determining collisions. It's not as easy as saying, well, you're moving in this direction, so you ran into that thing, so that's how far it is. It's not like that because you can break down the distance infinitely. If I have if I walk through a plane, like a wall, and I'm running 100 miles an hour, and I come up to a wall that's, a millimeter thick. How do you know that I hit the wall? Like, it's the process of figuring that out is really complicated. So I think what I might have to do is the recovery from each motion. But I'm going to have a loop higher out here where I will call, hey, move. I'm going to move 3 units forward. Let's say 3 meters in this tick. That'd be way too much, but whatever. Let's say 3 meters. What's the first thing I hit? And it goes, well, you moved a half a meter. And then you bumped into 2 things. You bumped into a wall on your left and a wall on your right. And here's the collision details. Now, out here, I'm going to have to figure out, what does that mean? My movement's not done. I want to keep moving. Unless, if I can. So it's like, okay, I'm embedded in... It's wherever it detected the collision, it's going to give me the collision information back. It's going to say, okay, you're embedded in this wall and in this wall. Let's say, a slowly narrowing hallway, and you're colliding with the ground because you're walking on the ground. So it'll have all 3 of those, and I'll come back out here and I'll have that information, and then I'll determine, okay, I bumped into all 3 of those. Actually, don't call again to move further forward, because I can't move anymore. This actually stops me because I slide along one wall, but that pushes me into the other wall, which stops me. This is going to be... It's going to be rough. It's going to be really rough. So I hate to say it, but I think I'm going to keep doing the hack for now because I need to make enough progress to keep wanting to work on this, and diving into something that difficult right now is not. I don't have enough of an interesting game to be able to move around and play in and try things in and add other stuff to if I have another idea, because I get a little tired of this. So I'm going to use the hack of, say, hey, do your physics step, do your rendering. Where did you end up? Oh, okay. Now I've updated the physics, or the simulation. So I do have to do a little bit of a weird thing here if I'm going to do that. So let's go to my C# code engine. So when I move, what I'm going to do is set your simulated position. Kind of going to do it twice. Like I'll set your, what's it called? I'll set the simulated position to not having moved. And then I'll do the rendering. Oh no. Okay, I need to figure out, I need to think on my own time about how I'm going to interact with the physics, because the rendering I want to have happen later. I want to say the simulation changed. Now here, move this rendered thing. But I want the physics step to happen. So anyway, I think it's just over an hour. I think there's a nice short stream to just figure out kind of what I'm doing to start with. I'm going to go ahead and sign off here, think about this stuff on my own, and come back to it next time. Well, if anybody comes by to watch, thank you. And let me see how this goes. It's going to be tricky. There's a lot of complicated stuff to do. Thank you.